Okay, let me talk about worksheet 2. I'll just kind of go through the ones I thought maybe you might have some trouble with. The beginning ones, remember, you're just asking yourself your base. 2 raised to what power gives you 1? 2 to the 0, so that's your logarithm. Most of these you probably can do without showing me much work. If you get to one like 5, where you aren't sure, like 1/3 raised to what power gives me 3 radical 27, write it out in exponential. Anytime you have a log, you want a log equation, so set it equal to x, and then put it in exponential form. So it's 1/3 raised to the x equals 3 times square root of 27. So when I do that, I have to think about 1/3. 1/3 is 3 to the negative first. So that became 3 raised to the negative x power. 3 radical 27, I thought of the 3 as 3 to the first. This I thought of as 27 was 3 to the third, but since I'm taking the square root of it, that's 3 to the 3/2 power, plus 1 would be 5/2. So it's 3 to the 5/2 power. So when you aren't sure, write the exponential, get them to be the same base. So this one, the base would be 3, and then just set your exponents equal. So positive x is going to equal negative 5/2. So any of those that you aren't sure of, do that if you need to. I did that also on number 9. I wasn't sure about that, so square root of 2 is 2 to the 1/2 x, had to equal 2 squared, so now I know the exponents have to be equal. The other one that you might have struggled on a little bit was 10. Remember, when you look at this, you're thinking about 3 raised to this log power, so I first made sure I combined that, the log base 3 of 5 divided by 4. If you aren't sure what that is, again, set it equal to x, because you're solving for x, and that's in exponential form, put it in log form. Log base 3 of x has to equal your power, which is log base 3 of 5/4. Then you can see that, oh yeah, x has to be 5/4. So anytime you're taking a base like 3, raised to the log of the same base, then you know your answer is just going to be whatever that is, because it works out like this every time. So if you just gave me an answer of 5/4, you're fine with that. Okay, then when we get to the equation stuff on worksheet 2, basically a couple different kinds of equations you have to think about. For log equations, if you have a log equal to a number, then remember, once you get it just one log equaling a number, you want to put it in exponential. So this one, 5 to the negative second is x. When you look at 13, 3 to the second power equals x squared plus 1. And then you just have to know how to solve those equations. Remember, whatever you solve for, you have to make sure you're taking the log of a positive. We also only take positive bases, so you will never have a 0, a 1, or any positive or any negative bases there. It has to be a positive number, and it can't be 1. So when I solve for this one, I got plus or minus 2 radical 2, and because I'm plugging it back in and squaring it, that's okay. I'm going to take the log of a positive. Same with number 14. 14 was 5 squared equaled what I was taking that log of. And now it's a quadratic, and I had to use quadratic formula to solve it. Be careful in one like 12. I saw some people that wanted to take 6 raised to that whole power equals 36. And that's true, but you don't want to, if it's not as in the exponent, the variable is not in the exponent, you don't want to make it into the exponent. So really, when you see that x is out here, you know to solve for x, I just need to subtract 3 and divide by 5. The one thing I did want you to notice on this one, though, is that log base 6 of 36 is 2. So before you simplify, you should know that that's 2, and then you can undo and solve for x. Okay? On the back, there were 2 more equations. This one, we talked about that, so you have to be a little bit careful because this is the log of all of that, and this is the log of 3x. This minus 4 is out here by itself. So that should be the trigger to tell you that, okay, I've got to get these logarithms together so that I can take the log of something equals negative 4. So if you subtract the log of 3x, log base 2 of 3x, the bases are the same, so I can write it as one logarithm, the log of the x minus 5 divided by 3x. So when you see that you have a number, make sure you always tell yourself to get the logs on one side and then use your property of logarithms. Then you put it in exponential. 2 to the negative fourth equals that value. Up here, 2 to the negative fourth, 1/16. To solve that, I just cross multiplied. 16 times x minus 5 equals 3x, and then I solve for x. Again, if you plug it back in, 80/13 will give you positive numbers for both of those, so you're good. 16 already was 2 logarithms set equal to each other, so that's the second kind of equation you have. When the log, as long as the bases are the same, if the logs are equal, then you know what you're taking the logs of have to be equal. So I set them equal as a quadratic, and I solved it. Domain issues. Domain, remember, the part about logarithms is just whatever you're taking the log of, set it greater than 0 and solve it. And so I think I had a mistake on the original answer key. This is x is greater than 3. This one, you set x plus 1 greater than 0. Doesn't matter what the base is. It could be natural log, common log, log base 5. Whatever you're taking the log of has to be greater than 0. So the only trick is when you get to ones like this and you set it greater than 0, now we're going to talk about what do you do when it's a quadratic. Well, find the roots, find out where it equals 0, and in this case it was a double root, so only at 1. And then find out on the left side of 1 and right side of 1, is it a positive value or a negative? In this case, they're both positive. So the only place where you would get a 0 would be when you put in a 1. So x can't be 1. This one, same thing. If you set x squared minus 1 greater than 0, factor it. You've got 2 roots, negative 1 and 1. Do your plus and your minus to figure out where is it positive, where is it negative, and I want to describe the positive one. So there's my answer for all the positives. 21 and 22, same thing. If you set that fraction greater than 0, remember you can't just multiply by x plus 1. You have to find your roots. So there's only a root at negative 1. On the left side it's negative. On the right side that fraction is positive. And I want the positives. So from negative 1 to infinity. This one had a couple roots. It had one at negative 1 in the numerator and one at 0 in the denominator. Circle both of those roots. Decide where is it positive and negative in between those. And I want the positives. So there was that answer. Okay, so this basically is the review part. Do you know if it's a fraction, if it's a quadratic, do you remember to put it on a number line and decide where it's a positive? The log part, the new learning was just, do you know that what you're taking the log of has to be greater than 0? All right, and then find the A was just making sure you realize that, you know, if you're given a log equation and I give you a point, you should be able to find the value of A, the base. So I said when x is 2, y is 2. So I put in y is 2, I put in x is 2. It's a log equation, so I put it in exponential. A squared has to equal 2. So if I take the square root of both sides, I get a equals plus or minus radical 2. But remember, your base cannot be negative. So I have to say my base is only radical 2. Even though this equation I solved for and I get plus or minus, my answer is just positive. And same with this one, I put in y is negative 4. I put in x is 1/2. In exponential, that's a to the negative fourth equals 1/2. To solve that equation, I raise this to the negative 1/4 power. So the power to a power, I get a to the first. So I have to take 1/2 to the negative 1/4 power, which means if I flip this, it becomes 2 raised to the positive 1/4. So remember, if you have a negative exponent, you have to take your base and you have to flip it. So it becomes 2 to the positive 1/4, which means I want to take the fourth root of 2. Okay, so they're just looking for the base there. So that's kind of worksheet 2, quick wrap up of how I did those problems.